Okay, so here we got this question, which basically relates to complex plane. So this is again a question which has got many parts, and the question at a glance is given here. Let's take a look at this. So you got a rule here which says that mod z minus iota is always equals to 1. Then the question asks you to write this in Cartesian form. This part would be considered fairly routine. Next one is the point of intersection of these two graphs. That would also be could be called routine, and many of you would be able to do that intuitively. Next part is, again, you're talking about these two rules, and you're required to draw their graphs on this Argand plane. Next question is basically again same as C, but this time you are required to now find your answer in Cartesian form. And D2 is a question which could be termed little bit tricky, because here you see something which is non-routine. And part E, again, you got two graphs, and but this time you got two regions here. It says that the length of the vector from 1 to z is always less than 1, and likewise here in the other formula as well, other expression as well. There are two sets, and you're trying to find the intersection, and then you need to find the area of the shaded region in this part here. So this finding the area basically can only be done once you have done the integration, but we'll still do this question using integration. Let's look at the solution. We start with 1a. So this rule, obviously what we have here is, I can write this rule in a little bit different form. So I have is equals to 1, and I can write that as 0 plus iota is equals to 1. Now if I do that, now I can interpret this geometrically. In fact, this question could be done geometrically as well as algebraically. We'll be doing this question geometrically. So what we see here is that this expression tells us that the length of vector from 0 plus iota to z is always equals to 1. And I can write that in words and say that the length of vector from 0, 1 to z always equal to 1. Obviously what it means is, okay, I don't need to divide that in two parts because we won't need that much room there, which also means that, which implies that z will lie on a circle with center at 0, 1 and radius equals to 1. So I can draw the diagram as well. So here we see this is my point 0, 1. You call it 0, 1, or if you look at Argand plane, then this is my vector iota, and from here z is always at a distance of 1. So that's what it's gonna look like. This will be 2, and that's the 0, 0 there. So all we need to find is our x and y. Our z will always be on this circle here, and obviously we can see that the x and y basically describe a circle here. So equation of the circle, if you can do some translation, then it will be x square plus y minus square whole square equals to 1. I think I can spend a couple of minutes here on how I got here. If you look at this circle, the circle which we normally see in its simplest form is this. Sorry, this but I think it's served the purpose. So this is my circle, and this circle, let me say this is r square. So this circle has got radius is r, from here to here it is r, and center is at 0, 0. So if you want to translate this circle, then all you need to do is you need to replace your x and y with something. So let me explain. If you move this circle to the left, to the right, in the positive x direction by a unit, then the new circle would be, let me write here, shifted to right by a. Then my equation of the circle will be, I'll replace x with x minus a, and that's my new circle, which is shifted to the right in the positive x direction. If you move in the negative x direction, then your a will be negative. Okay, what if you move this circle in the positive y direction? So shifted in positive y direction by a units, then obviously this circle's, the new circle, the translated circle, you can get that by replacing y with y minus a. If you keep this in mind, you will not have any trouble in finding the equation of this circle. This circle is nothing but a circle which was x square plus y square equals to 1, and it has been, if this circle is your x square plus y square equals to 1, then you move it for this one here, you're moving it one step in the positive y direction, so it becomes, you replace y with y minus 1, and that is your answer. You don't need to write all these things, that's just I have explained, so I'll rub that out. Okay, let's look at part 2 of the question here. Find the point of intersection of, there are two rules here, and you can see the first one is, I can write the first rule. First rule is mod z minus iota equals to 1, and as like last time, I'll replace it with, I'll just slightly change it so that it looks a bit familiar. It is more convenient and more easy to interpret geometrically now. And second rule is z minus 1 equals to 1, which tells you that z minus 1 plus 0 iota equals to 1. So that is this one. It says that your z is always a distance of 1 unit from a point, from the point 0, 1, and this is, the z is always 1 unit away from the point 1, 0. Right, so basically if I want to show these 2 points, I can show them here. So first rule says that this is my 0, 1, or call it vector iota. Another one is, this is my other one. Yeah, so, and my z is such that it is always at a distance of 1 from this and at a distance of 1 from this. So this is my point 1, 0, and that's my point 0, 1. So obviously you can see one point is this point, your origin is at a distance of 1 from both of them. This is 1 and that is 1. And likewise you will have another point here as well. So this point will be, if you look at that point will be, this is 1 and that's 1, so you will have coordinate of 1, 1. So the required point of intersection are 0, 0 and 1, 1. Will be in subsequent problems in part C and D, will be elaborating more on this thing here. This will be finding these points geometrically as well, so algebraically as well. But this question, as far as this question is concerned, you just need to do this, and just you need to use some sort of intuition, and you will be able to get these 2 points. Now here it says sketch and label the graph. So the same thing, we're still working on this. So what we have here is you have a circle. For this one, you have a circle starting from here, and for that one, you got a circle starting from here with that center. So, okay, circle of radius 1. So you have one here, one here, one here, and one here. So I will have a circle going like this. So okay, I'll try to draw it as correctly as possible. So there you go, and from there, yeah, and then likewise I go from here. All I'm doing is I need to keep in mind that the circle is always at a distance of 1 from their respective centers. Obviously that is a circle, so these are the point. Now that one is my rule number 1. I'll say that's my rule, and this circle is this rule. Yeah, so you can see what here tells it. It says that the length of the vector z is always 1 from iota. So it's a circle, as already discussed in part B. Find the equation of the straight line which passes through the point of intersection of these two rules. So we got 2 rules here, and corresponding to each rule we will have a circle. So z minus iota equals to 1, which we are saying that is z minus 0 plus iota equals to 1, and it's a circle with center equals to 0, 1 and r equals to 1. So therefore its equation is circle has, now you need to see that your simplest circle centered at the center at the origin, that circle, if you move it in a positive y direction by 1 step, you get this circle. So all we need to do is we need to replace y with y minus 1, and that would give us our circle. Likewise, other one is z minus 1 equals to 1, which tells us that z minus 1 plus 0 iota equals to 1, and that is a circle with center equals to 1, 0 and radius equals to 1, and therefore equation is x minus 1 whole square plus y square is equals to 1. So what we've done is your simplest circle x square plus y square equals to 1 has been shifted by 1 step in the positive direction. So that's why we replaced x with x minus 1 here. And now all we need to find is we need to find the point of intersection, which is just like solving a pair of simultaneous equations. So these are our 2 circles, and we need to simultaneously solve them. So what we do is very simple. I'll say I'll do 1 minus 2. When I do 1 minus 2, I get x square minus x minus 1 whole square plus 0. I can solve it, and I think I'll need more room here, so I'll just divide it in 2 so that work from here. So here, this is difference of 2 square, and that one is also difference of 2 squares. So this is a plus b, a minus b. So plus x minus 1, x minus x plus 1. That is a plus b, a minus b. This one, again, the difference of 2 squares. So a plus b, a minus b equals to 0. This gives you 2x minus 1 times 1 plus 2y minus 1 minus 1 equals to 0, and that gives you 2x minus 1 minus 2 plus 1 equal to 0. I go to the next column here. So what we have is 2x minus 2y equals to 0, x equals to y. And obviously, if we look at our previous, the 2 points of intersection that we find that both of them lie on this line, x equals to y. So that's your solution for this question. Okay, next one is, it's a little bit tricky. You'll need to really think. The straight line found in part D1 can be expressed in the form z equals to a z bar, where a is a complex number. So we need to find a so that these two are equal. And it will still prescribe, it will still give that equation x equal to y. So let's take a look. Because this z equals to a z bar, let me do it in 2 columns here, which gives me x plus iota y is equals to a x minus iota y, and that gives me a equals to x plus iota y, x minus iota y, and I can simplify that using x plus iota y. I think you all know what I'm going to do here. I'm going to multiply with the conjugate of the denominator. That implies that this is equals to x square plus y iota square plus 2xy iota divided by x square minus iota squared y square, and I get x squared. Iota squared is minus 1, so that's become x squared, x squared minus y square 2xy iota. Now we know that our equation is x equals to y, so as we have, that's our equation. That's what we are trying to look at. We are trying to derive. In fact, let me put it in a different way, that this equation basically has the Cartesian equivalent of being x equals to y. So we have x equals to y here. So let's say x equal to, say, x equals to y equals to, say, b. So then what we get here is a equals to b square minus b square 2b square divided by 2b square. So this cancels out, becomes 0. Then 2 square divided by 2 square is equals to I. So that's the value we wanted, and we can check it whether this will give us x equals to y or not. We can check. So check, we got z is equals to iota z bar, because this is your, okay, let me just say g equals to a z bar, which is basically putting the value of a. I am saying that this should give me the Cartesian equivalent x equals to y. So let's do this. X plus iota y is equals to iota x minus iota y, x plus iota y is equals to iota x minus iota y square. That gives you is equals to, sorry, it's not iota square, it's just, no, not y square, yeah, that's y. And this iota square is minus 1, and minus becomes y plus iota xy. And if you can see that these two complex numbers are equal, it means their real parts and imaginary parts should be equal, and that implies that x equals to y. So it checks out. We see that this equation is same as x equals to y, and that's what we wanted. Okay, so next one here is the same equation, but this time it's an inequality. So you are given two sets here. The first set says that z is a complex number such that the length of the z from 1 is always less than equal to 1. So in the previous question, the length was always equal to 1. Now this is less than 1. So it will be the area within the circle. The same way here, you got a z here, and z minus iota less than equals to 1 means that the length of vector from iota to z is always less than 1. In the previous case, we dealt with cases where this was equal to 1, but this time it is less than equal to 1. So basically we are looking at the region within the circle. Again, so similar to the previous ones, we got similar to the previous one, we can draw the diagram here and we can shade them. So the first circle, we already found that. Here we are looking for the area inside the circle x minus 1 whole square plus y square equal to 1, and that this area we are looking at the area within the circle of x square, circle defined by, sorry, not y square, y minus 1 whole square equals to 1. So we can draw these two circles here just like we do last time. So that point, this point, this point. So this drawing is if it were paper, I would probably be able to do a better job of it, but yeah. So here we go. Yeah, so this is my, I'll say this is my rule. This is reason A, and that this is reason A, and that is reason B. So reason A is within this circle, so that's my reason. Just remember, just note down that the boundary of the circle is also included here, because this sign here, it says less than equal to. So the equal to reason is equal to condition is also included in our set. So you need to have a solid circle here. And for that one, I think I can show for your benefit as to which reason corresponds to which. Let me write it here. Let me make it proper, which is to say that less than equals to 1. So now it shows the area we're talking about, and here less than equal to 1 is the region within the circle. Okay, so that is done. That's what you were required to do in this question, and you are done. Just remember the point of coordinates of this are 1, 1, because that's where these two circles intersect, and you got a 0, 0 as well. All right, so next part is finding the area. So here we are trying to find this area here, that circle, this area, that intersection, because this intersection here, this means intersection, which means the area of intersection of these two circles. So we can find this area using integration, but here integration, it would be a little bit tricky, so we need to be really careful what we are doing. So let me go with this. Let me talk about it. So this circle is, that circle is your, already I found that circle is x square plus y minus 1 square less than equals to 1. So but when you want to use integration to find area, you need to write your function in the form of y equal as a proper function as a proper function. So let's write this as y equal to something. So we are just looking at the definition of the circle. So circle is equals to 1. So what I have here is y minus 1 square is equals to 1 minus x square. Then I get y minus 1 is equals to plus minus square root of 1 minus x square, and y is equals to 1 plus minus square root of 1 minus x square. And we have to be really careful here, because when we look at a circle equation like x square plus y square is equals to 1, we'll need to talk a little bit about it. So I just want to digress a little bit here. So if you have this equation of your circle x square plus y square equals to 1, then your y is equals to plus minus square root of 1 minus x square. Now this does not represent a proper function. Why? Because if you draw a circle, you get it like this, and it doesn't pass the vertical line test. So it is not exactly a function. So what we do, we find like this. Now if you have that kind of expression here, what you have is you got two functions. One is y equals to plus 1 minus x square, and other is equals to y square root of 1 minus x square. So one of these, now they are all of them, both of these are individually proper functions, because this one here gives you upper part of the circle, and that one here gives you lower part of the circle, right? And we have to take that into account when we try to decide what area to integrate and what limits to use and what functions to use to find the area here. You cannot use both of them. So look at this. Let's go back to this case here. So this circle I got this. That's the equation of my circle here, and I got plus and minus. So basically, one plus gives me upper half, and y gives me the lower half here. To find this area, all I need is the lower part of the circle. So the equation that I would use for finding the area would be y is equals to 1 minus square root of 1 minus x square, because that gives me the lower part of the circle. Okay, so if we got that part of the circle, lower part of this circle, but now we want the upper part of this circle. So that second circle is, let me box it so that we know that we are going to use this, and we need to find the upper part of this circle. So we need to find the equation of this circle. Equation of this circle is y minus 1 whole square, x minus 1 whole square plus y square equal to 1. Y square is equals to 1 minus x minus whole square, and that gives you y equal to plus minus 1 minus x minus 1 whole square. Again, we'll get two parts of the circle. If you take a plus here, you will get the upper part, and if you take a minus here, you will get a lower part. So to find the area of this shaded region, we need to use the upper part of the circle. So the circle that we are going to use is the upper part, and that is y is equals to plus square root of 1 minus x minus 1 x whole square. That is the equation we are going to use. Okay, once we have identified what functions to use for finding this area, now it's really finding area in itself is really straightforward. So I'll say required. You need to just recall your concepts of integration. Required area is, first I find that frame from here between 0 to 1 under this circle here. I need to find this area, so I will do 0 to 1, and I will use this upper part here, square root 1 minus x minus 1 whole square dx, and from that I need to remove this area, that lower part here. So that will be 0 to 1 minus square root of 1 minus x square, and I just use the calculator, and my calculator gives me 0.7854 here and 0.2146 here, and the actual value of the shaded area is this square. And that's where we are going to stop.